So welcome everyone. I'm gonna talk about language server for about an hour. I haven't prepared anything, so I'm gonna be freestyling. Um, I don't. You can tell me with show of hands, except for Aaron, who's skilled with the ways of language server, who's seen Elena's introduction that I linked to the issue. Um, all right, Dennis. I'm gonna quickly go over it as well. So I'll do some a basic introduction of the just what language server is and how it communicates with the VS Code extension and other editors, and then we'll be focusing on the new WebView plugin architecture that John created, and we'll discover it as we go. I don't quite know it that well yet either. And we'll have a look how to connect the VS Code extension with language server and do some debugging. That's probably the most useful thing to understand how these two communicate and how you run them locally alongside each other, those two systems. So without further ado, let me close my calendar, share the screen. Um, Here we go. So uh, I'll start with Excalibur. Here we've got language server and we've got VS, the client. In this case, I'll use VS Code extension just because that's the system that I work in the most, but JetBrains and Visual Studio are equivalent mostly. Actually, we have VS Code extension and we have the language server. The important thing to know is that the language server lives in a separate project and it's started as a separate process most of the times. I'm not going to be going into details how the web IDE works. In the web IDE, it's a web worker, but for all intents and purposes, we'll be just thinking about the language server as another process that is started by your IDE. And what happens, you start the process and you connect to standard input and output and use that to pass JSON RPC messages around. So if you have a look, this is a good place to start with figuring out what language server can do. Here is the base protocol, JSON RPC, and pretty much it's some kind of it's a text, some header, and then it's a JSON payload. And there are two types of messages, which is quite important. You can either send through notifications or request. And the key difference between them, the key difference between them is that, never mind, is that when you send a notification, you don't expect anything in the return. Also, the layer, the abstraction that John created for creating like a little plugins in the language server that then get their counterpart as a web view or part of the extension in the IDE. Those also use the same paradigm of having notifications where you just send some information and you don't expect anything in return, and request where for every request you have to have a response. And there actually always has to be a response. So for example, when the IDE is asking for code suggestions, and for whatever reason we can't provide any, maybe the model didn't come up with any, or there was some network error, we have to return an empty array. There has to be a response for every request in JSON RPC. So that's the basic. Also, you would notice when I'm talking about language server connecting to standard input output, there is important not to console log anything to standard output because that would be read as a JSON RPC messages. However, there is already how you call it, monkey patching, I guess, of the console log. So anytime you would use console log in language server, it just uses console error and outputs it on the standard error, or not standard, on the error output. So that's roughly the introduction. Now let's have a look at the language server project. So that would be here. It's structured in a way that most of the code lives in a common folder, source common, because we want to share as much of the code as possible between the web IDE, which runs in a browser, and the normal language server process that runs on desktop. And then the the entry point directly to the language server is this node main file. And here you would see the key part that we are, I think this is, let me find it. I'm looking for the code that calls into the Microsoft library that starts the language server. You probably won't have to do much with this plumbing, but it's still good to know. Somewhere where we get connection. Here we go, create connection. And create connection, yep, create connection is not our function. That's something that we get out of the VS Code language server node library. So that starts the language server, not starts, the process is already started, but this initializes the JSON RPC connection with all the JSON RPC handling out of the box. And then there is somewhere in connection file here, you are registering all the handlers as you would, for example, if you had an express router or something similar. There is a new design pattern that we are using. First, I'll now go into technical details pretty much of how the language server is implemented. Are there any questions that you would like to ask about this, what I covered so far?
I have one. So
of course
the connection. so we connect to the Microsoft language server. So the Microsoft I would like to understand the difference. So the language server project that we have and Microsoft language server, these are two different things, right? We did not develop Microsoft language server. We
Correct.
develop our own language server, which is based on Microsoft language server, which does communicate with the language server protocol, right?
The last bit communicates with the language server protocol. Yes, you're
yes.
Absolutely right. The Microsoft's library, the VS Code language server that we are using, and its different flavors like the VS Code Node language server, you can understand that as the Express library that you would use if you are writing HTTP server in JavaScript, or any like a library that manages HTTP connections. The difference here is that this library manages the JSON RPC communication and provides few other niceties around the language server protocol.
Mm-hmm. Okay, thanks.
Yeah, like if we have a look, the reason why it's called VS Code language server, it's a also interesting piece of trivia. It's because the language server has been created, or the protocol has been created as a part of VS Code development, where the Microsoft team wanted to decouple. They didn't want to follow the previous IDEs where every IDE had to create their own language support for any language that they want to support, but they wanted to decouple the editor from the language support. And so for everyone more or less who's writing a JavaScript or TypeScript language server, not for those languages, but language server implemented in JavaScript or TypeScript, is using this library because it's de facto standard. If you are writing language server in Go or Rust, you need to use a different library. All right, now I'll show you the new pattern that we are using for implementing, like for putting dependencies together, for just combining all the logic together. We use a little class or like a file called dependency, and that's the important parts of it are that you are able, actually, I'm going to show you how it works rather than show you the implementation. So,
Thomas, can I kindly
con
ask you to increase font just a little?
yes, yes,
Because
yes, yes.
we are going deeper and deeper in the technical details. It's just harder to follow.
Hmm.
Thanks.
Makes perfect sense. And on the video, uh, recorded video, it probably would also be barely readable. I don't think it's going to be outputted in 4K, so that's a good point. So, we when we are writing a new piece of functionality, we would usually create a service that is powering the functionality. It's a class that implements some interface, and then we have this little syntactical, not sugar, but this, let's say, boilerplate where and it's a TypeScript specificity where you pretty much overload the identifier. Here it's interface config service, which in TypeScript, these interfaces, all type information in TypeScript gets removed on compilation, and what you are left with is just JavaScript without any type information. And so this is compile time variable, and this is a runtime variable. And to make the syntax look nice, we are using the same name. And what we use this for is that then we say that the default config service implements config service and can be used in our dependency injection framework as config service. And this is pretty much all you have to do when you want to introduce new service or a new piece of logic. You you decide what interface your service needs. You create this interface ID for the interface, and then you implement it, but you make sure that it's marked as injectable. And then if it needs any dependencies, let's have a look at, let's say, what a good service would be. Let's say API. Well, here we go. The GitLab API client also needs these dependencies, and that's how you define it. So pretty much if you are creating a new service, search for injectable, or just have a look at the config service, the API service, and other like that. You can follow the pattern. I probably won't go into detail how this is implemented. It's an implementation detail that won't be that much of use to you. Cool. So with this out of the way, let's have a look at how, since we are all interested in the workflow, let's have a look how we would implement, or how the workflow is implemented so far.
I have
There
a
is
question.
Mhm.
Um, can you give the example of the services? Like I was typing, I missed the example in the API. But what are the examples of these services? Like what is the use case where one would need to write a new service?
Any logic that would require a state outside of one request response or notification cycle would be in service. So examples of it is the config service that I've shown that manages, because once you start a language server, and I'll just quickly go to yeah, I'll show it from the connection service. So there is initialize. No, I'll talk about it first. So the connection, once you start language server, you get from the client some configuration as a JSON RPC message. And that configuration is like, it's a stateless thing the language server needs to remember in across all the requests that it's handling. And so you would have the config service that reacts to, here we go. Let me find it. All right, so the config service actually doesn't directly work with the uh, connection, but it manages all the state. Every time you change the language server configuration, you call this set or merge methods, And this service then uses this onConfig change event emitter that notifies everyone who's interested about config change. For example, that would be the API client, where API client says, I need a config service to function. And then this argument list needs to match or this array needs to match the arguments in constructor. And here we say config service, as soon as you change, we will have a look at, yeah, we will get the token and the URL of the GitLab instance, and we make some API requests to make sure that the API is working. And so that happens on every config change in the config service. And so this is the kind of logic that you would have. Then maybe your service needs access GitLab API. So it would depend on this GitLab API client. And you would want to listen on API reconfigured every time that the client reconfigured API. Maybe you want to, let's say that you had a version, like a GitLab instance version service the only purpose for it would be remembering what's your GitLab instance version. And you would say, my service needs this GitLab API client as a dependency. And in a constructor, I'm just going to call on that dependency on API reconfigured. And every time API is reconfigured, I'm going to call the GitLab API and ask for the version, GitLab instance version on that. Does it make sense?
I would wish to say yes, but I will need to rewatch this a couple of times, I guess. I don't think it makes sense to
This is
reiterate
actually
this, but yeah.
this is actually quite important. I don't mind spending some
Okay.
time on it. The way how the language server manages state would be really good to understand for really like for any feature that's implemented in language server.
So to put it like in the TLDR, the language server works as the set of kinda independent services that communicate with the events and that expose the events that other can listen on. Is there any like the pattern on the list that helps developer to see like, okay, what is the list of all the events or how we would add the new event? I think that's two questions, like how we learn quickly what are the events that are actually exposed right now. And the other is like, okay, there's no event that I would need. How can I add the new event that would be necessary for my use case?
Gotcha. That was a good summary. That like ideally, it's not this pattern that I'm showing is used in maybe like 30% of the language server, and we are slowly migrating the rest of the language server to it. So it's not the whole language server doesn't work this way yet. But it's fair to say that in the ideal scenario, you have services that are responsible for some piece of business logic and then expose this business logic as methods and also events that something might change. The thing that there is one thing that is probably not clear, and that is that the events are not global. Every class or every service creates this one or more event emitters, and that's a node. This is isomorphic, but it's a most common way to handle events in Node, and it's a one instance or object that allows you to pretty much register listeners like this, and then fire the events like this. And so you wouldn't have a list of all events available. You would want to go to, I want to use GitLab API, so I'm going to go to the API service, which unfortunately here it's not called.
The events are local to the services, right?
Correct.
Right.
And so when you want to list, for example, as I said, you want to, let's say that we are creating, and I'll do it quick, somewhere here, for example, new file, version service, DS, right? And you would want to create class version service, and that actually it would be interface first, and the interface would have only like one thing, like a GitLab, probably like, yeah, get GitLab version returns string, for example, I don't know. And that's the interface. Then you would be doing export const. This is the, uh, it would have the same name as the interface. And here we go. If I can type equals create interface ID, the string here is arbitrary, but we just put there the same because some logging messages might be nicer if you actually get the right interface ID. And then you would have export class default version service implements version service. And now the key part will be that constructor needs we will have like a API client, I think it's called. So private API client, GitLab API client, and then the constructor accepts API client like this. And we would want to do, and there would be like a version string. And every time API client, this is how we are using the event. So on API reconfigured. This means that the API config changed. Maybe it's as simple as the OAuth token has been refreshed in the IDE. And so you would expect that it's still the same instance, same user, but it could be that the user changed their token and it's a different user or even a different instance ID. And so we would create this listener where we have access to is invalid state, which is important. If not is invalid state, then we would do, I don't know, something, probably remove the version or I don't know. And otherwise we just call get version. I wonder why doesn't exist. Fetch from API, get version. There should be, I can't find it right now.
I think
I
we have
can
one.
if
I think we have one in VS Code, but we don't have a constant in a language server version.
uh-huh. But we should have like I thought that something needs a version in here. Instance version, get GitLab instance version. Okay, so it's a private method. Okay, we could call here get instance version. So that's a little bit futile because you're just forwarding. Ooh, and maybe it's not even in the public. I see
It's
that
just
it's
instance version. It's not get, it's instance
gotcha,
version.
gotcha. Okay, so this is, since the API client did all the work, this is probably not the best example, but like you could make an API call here and update the version. And this is then, so, and if you wanted to expose that the version changed, you would go here and say event emitter. Now you have to use the correct one from events. Here you create one new event emitter, and then you would probably expose a method saying on version change. And this is callback, probably something like this with, I don't know what I've done wrong. course. On version change is a function that receives a callback. TypeScript is hard and returns void, maybe this. Yeah, I got a little bit lost in all the quotes and defining the TypeScript type for a function. Not gonna go down this rabbit hole. You probably get the
Thomas, what and we have to mark the class as injectable, right?
Yeah, correct. Let's do that also. But I'm just gonna quickly have a look how we define the type of these listeners in, for example, this interface. Listener. Yeah, of course. You would want to return disposable. That's a good point. Because disposable is a kind of specialty of the VS Code ecosystem. And it's an interface that provides one method, dispose. And that's the way how you would tear down like when you create something that could leak memory, like add a listener, you need to make sure that if you don't need a listener anymore, you are calling disposable on whatever you get when you were registering the listener. And here this is going to be just string. And now the injectable part, we are missing. Why is this complaining? Yeah, there is not the on version change. Is that okay if I'll just quickly implement it? It shouldn't take too long. On version change listener disposable. And here we can say this event emitter, event, is it, or fire? What is the, I thought that it's event, emit, right, emit. Here you use some string. Ideally, you would just put the string here. That's the identifier of that particular event. So here it would be probably version. The only time where you need it is here if you would be now calling this event emitter. Yeah, and here you don't want to do emit, but you want to do on version change and register the listener. And you want to return the disposable where remove listener, like this. If it makes sense, pretty much what it's all centered around this event emitter, where when you are registering the listener, you register it to the event emitter, but the event emitter interface or class needs identifier for the event, but that only needs to match these other, like it's a local, it's a private to this class. It's not something that the outside would see. Yeah, for the outside, the interface is registering the listener like this. And now the last bit would be that you add the injectable here, the version service, and as a dependency, you need GitLab API client. And I don't know why it's not compiling. But this is how it would work. And then what can you do when you have injectable like this? If all the dependencies of that injectable are already present in the container, which in this case they would be, you can just open the place where we are initializing this whole dependency framework, and you would pass it like here in all the list of other injectables. So it would be default version service, and that would be it. Any other injectable that it would later need the version service could just declare it as a dependency like this, and that would work. So any questions around this part?
So to confirm, all the events that we can listen or basically callbacks, I would say, should be listed in the interface, like at the very top of at the top of the service that we actually like reading. So when I'm
Correct.
trying to understand, like, okay, what are the callbacks that the service offers that I could listen on, or I could register to listen on, that would be listed in the interface with their signatures as well, so I can know how to prepare the callbacks that I want to be that I want to be invoked. Cool.
Yeah. Yes. Yes. You would know. You would have them in the interface specified. There is you just reminded me there is like two things that two ways how you can work with the service. And one is this, that they are reacting to events. And that's usually, you would use that for something that happens quite rarely and has some latency attached to it. Like here, when the API reconfigures, it's making few API requests to check that the token is valid and not. And the other way to work with services is invoking methods on them. And that's the preferable way because it's simpler to follow. And so if so you would have, when you have a service, like there would be the events coming to it, like I don't know, API was reconfigured, and then API was reconfigured, but there would be also the normal method invocations like get me your data. And the absolute, like you just want to do absolute minimum in the events because that's just in another level of indirection and it complicates things, especially if something's not asynchronous. Always make it as a method that will do the computation when you ask it, because when the language server is performant enough, especially when you consider that for most of the things, it's like for most of its features, it makes API requests that take hundreds of milliseconds. So never think like, oh, I need to traverse this array of 50 elements, and that would be like such a computationally heavy thing that I'll just do it as an event that happens once. But like, if it's not asynchronous and not API call, don't try to do it on events. Just do it when you need it, because like the user won't be pressing keys fast enough to make your code the bottleneck. So this is how we would like the language server to be structured. We have 20 minutes left, and let's try to get to the web view part. So I'll just first show you, like we were able to kind of cobble together the VS Code extension part, so it a little bit works. I'll show you that. Then I show you how I connect those two systems together, and then we'll try to trace how the web view gets from the language server to the VS Code extension. So let's have a look whether it still works or whether I broke something in my local development. Okay, it works. So these two web views are coming from the language server. These, what we see here, the web views themselves implemented in language server, they are in the main branch. That's available to you right now if you check out the project and run it off main. However, the integration into VS Code, that's not yet in main branch and won't be probably today because it needs a little bit more work. But what we've done is that if you, it's all behind feature flag. So we are going to develop this not and like have it on a main in the main branch. If you disable the feature flag, this uses the normal web view that we are so far using for Duo Chat. That web view is implemented in the VS Code extension. And if you enable that feature flag, we instead switch into fetching over HTTP connection, fetching the web views from the language server. So now with this, I'll might result to the Excalibur again. But maybe first I'll show how these two projects are connected. So for that, I'll go to command line, make it bigger. And here we have the language server project on main. And well, how we are using Yalk to connect these two, connect VS Code extension and the language server together. That's a way how you can use your local npm module as and use it in some other project, like if it was a remote npm module. We don't use the npm link that you might be familiar with, because there was an issue with how node modules dependencies are handled in npm link, and they were clashing with the VS Code extension. So we had to use Yalk. Now, how this works? There is a command that Angelo implemented, which is really cool. If you have the VS Code extension, so here, if I'll just show you where I am in my, oops. So in my, on my hard drive, I'm in workspace, GitLab LSP, and then I have the extension, which is in the same folder, just called GitLab VS Code extension. That's the default name of the project on GitLab. And now if you structure your two projects this way, so they are in the same folder and they have the default names, you can just run, and I'm going to show you. So the VS Code extension is clean, the project. And so here, I'll run this command, and that builds the whole language server and the web views. And then it runs all the Yalk commands to publish the temporary npm module. And then it goes into the VS Code extension project and changes the reference to the language server. So now you see that if I go git status, the package.json has changed. And if I do diff, instead of pointing to the remote node module, we are pointing to the local Yalk. That's all that you have to really do to have the latest language server available. Now, another important thing that to keep in mind, this is a watch script, so it keeps watching. With the web views, we haven't developed them in Anger, so I'm not sure how well it watches the changes in web views. That's something that we will need to test. But the normal changes to the language server code, as soon as you make a change, this will rebuild it and update it in the VS Code extension. And what's really cool is that when you run it, in place copies the language server bundle into the like a built extension. And what I mean by that is that now you just can run restart language server, and that will give you the latest. Now the language server has restarted, and whatever changes you made are already available here without you having to restart the extension, which takes a little bit longer. So it gives you quick feedback. Okay, so this is how you connect those two projects together. Let's try to trace how the web views work. So here in the web view in the VS Code extension and in other editors, in VS Code and in other editors as well, it's just a browser page with a little bit of a runtime extra features. Like, for example, the VS Code web views allow you to communicate via messages with the extension both ways. But we don't need that because the web views live as a normal website in the language server. If I'll have a look here where we let me find it. I'm now looking for where the language server is running, and the best way to do that would be probably checking whether checking the language server logs. So you can always show the, just going to put this away. You can always show the output here, and in output, you can, I'll make it a little bit bigger again. You see there are different logs. There is a second language server because we restarted the language server. This is the one that we exited, and this is the one that runs currently. And at the top, the language server logs where it starts the HTTP server. And so we can go to this URL and say webview and do our workflow. So webviews maybe.
You can just remove the workflow and you can get the list of all the web views available there. But it's going to be WebView. You missed I. WebView VI.
All right, that explains it then.
Yeah.
I can't see these things. If there wasn't spell checker, I would never get a entry-level job at, I don't know, McDonald's, like without a spell checker. So WebView, do a workflow then. All right, so this is the web view that you see in the editor. It's the same thing. And the chat is, I think, just chat. So yeah, that's again the same thing that you see here. Now let's have a look how these web pages get into the editor. There is a web view controller, and this is gonna change. So just look at this as a, I need to go to the actual project. Just look at this as the like idea or the overall pattern that we want to use, but don't try to remember the names of the classes. WebView controller. Here we go. So when you are initializing a WebView, VS Code wants from you an initial HTML that the website shows. That's usually how you would inject all the code and whatnot, like the View app that we use for chat. But here it's very simple. We only say there is going to be an iframe. We style it so it takes the full viewport, and the iframe points to that WebView URL that we get from language server, and that's really it. So that's how it gets shown here. Now the idea is that when you have a, let's go to Excalibur. You have the web view, which is a web page. Then you, I'll just write black, and then you have a plugin. I'll show you that in a second. Plugin is the code that like the web view exchanges messages with. And then you have the extension. But these not necessarily, usually the web view is shown in the extension, but as you saw here, it doesn't have to be. The key way to think about this is that the web view always communicates with the plugin, and the extension always communicates with the plugin. So there is no, like the web view is not directly communicating with the extension. That's from the, because it's in an iframe, there is no easy communication channel between the extension and the web view. And we don't mind because the extension is going to be driving the plugin, and the plugin will reflect the state in the web view. Now for the way how we exchange the, is this clear? Any questions? Because next thing I'll just do is
just a note probably, which is important. So the web view and plugin, they live on the language server side, and the extension lives on the extension side, right? So probably you will cover this, I guess now, but the main thing is how to set up these communication lines, right?
Correct. Yeah, that's 100% right. The web view is an app that gets compiled as a static website, pretty much, in the language server, and then it knows how to. It uses, in the desktop version, it uses WebSockets to communicate with with the plugin. And so it's just normal static website, initializes itself, initializes the WebSocket connection that's seeded to the web view and communicates with the plugin.
I think the important part to mention here is, which is also very confusing part, is that technically there are two web views. There is this one web view, which is the functional application in the language server, but on the extension side, it's also the web view technically, which is very dummy, which just pulls in the web view from language server, right? So, but there are two web views technically.
Gotcha. Yeah, that's right. That could be confusing. So if I'll copy this, remove this, and call it also a web view, and put it in all the way to the back. So it's roughly like this. This has an iframe, and that points to the different web view. So the web view is a concept from the name, at least that I know of, is a concept from the VS Code, that they call all these web pages that are in the extensions web views. That's where we took it from. But Dennis is 100% right. We create web views here that are very thin shell on top of the iframe website that lives at runtime. It lives in that web view, the web view executes it, but it's served by a HTTP connection. So yeah, that's a good point. So
yeah.
This is like a WebSocket connection, WebSocket communication. That's once the web view is initialized, but initially it comes here, as you saw the URL would be like this, and it's served over a normal HTTP connection from the local host. So
Yeah.
I don't know, something like this.
It's important to note as well, like the green web view, there's the extension web view where the extensions like JetBrains and VS Code have a concept of web view where you render some websites, some URL. And then what we have is we're just hosting like in each extension, we're just going to host like a dummy iframe to render the static websites. So like the blue web view for like inside of the language server, we're calling a web view today. We can change the name later. There's some talks about, hey, we can maybe call it a provider plugin or like something, like some other way to name it, because that could technically be a JSON API that we're providing, right? If we wanted to like proxy to the REST API, but it's like the blue web view though, like the language server web view, that's also something you can request from NeoVim or other extensions that don't actually have web views built into them.
So the main point is the blue web view is kind of shared part, which is universal across all the possible IDEs supporting language server, while the green web view is going to be implemented for every single IDE.
100%. So this is part of the language server. And if we are lucky, it's going to be identical. The blue parts are going to be implemented once and working the same in all the IDEs. The only tricky part, well, not tricky, but the part that's going to differ in every IDE is going to be whatever we implement here. Yeah, I'll do this. It's like a plugin extension part. And in the chat, you can imagine this as, for example, the chat needs to know what you highlighted, right? If you want to like highlight something and say, now I want to talk, maybe it doesn't at the moment, but it might later. I'll just put it the normal chat here. Maybe you highlight this and you say, tell me more about the code that I highlighted. And you would expect that the plugin here, where are we? The plugin knows about highlighted code, but that's not something the language server knows about. So this part for each plugin, there will have to be some business logic that says, oh, somebody highlighted some code. I'm going to let the language server know that the code is highlighted, something like that. So all of these custom interactions with the IDE that can be done. The language server actually has a lot of information about your project. Like it knows the folder it is in, it knows what files you have open, it knows all the changes that you are making to those files. There are things called code actions, which lets you, like, let's say if I'm here and I highlight a piece of code, I would expect here source action. Yeah, I think that these like come from the language server. Like language server can tell you that I'm not 100% certain that these particular actions come from language server, the TypeScript language server. I think they do, but I'm not sure. But there is a mechanism where you can like dynamically tell the editor on your source code that the language server support, you can do these actions and the language server can serve them. So there is a lot of ways how you can already natively leverage the information that language server has, but there are going to be parts, or if you want to do some fancy, like let's say that here in the extension, we have a tree view. And if you wanted to somehow gather events or information about the user's interaction with the tree view, that's not something that the language server knows about. So that would also live in this extension logic. Does that make sense?
It does. How do we connect extension and the plugin? How do we connect plugin and WebView? This is the essential part, and we have only 3 minutes left. So like these arrows you have, what is the API here? How do we connect WebView to plugin and the extension to plugin so that we could set up communication between WebView and extension?
So the WebView and the extension, that will be an easy part, I'd say, because that's something that John has been working extensively. And so there should be already an examples. Like I think that now when I'm pressing this Fibonacci calculated, yeah, so this comes from the plugin, and we can have a look at how that's implemented. However, the other part that you asked about then is the one where we are talking with the extension. There is the message bus, and the plumbing or framework for it is ready, but I don't think we have any existing examples of how that's done.
So for now, we just have the established communication between WebView and the plugin, right?
Correct.
Using the message bus.
Correct. And that is, let's have a look how that's done. So if we just go to where the web views live, so the Duo chat, for example, that is powering the little calculator, even though John already has next iteration of it where there is actually chat. We have got the app and a plugin. That's roughly the structure that we would imagine. Plugin is the code that lives in the language server, and the app is the static website that then communicates with gets served and communicates with the plugin. So the plugin, I would expect, has the right. Okay.
We can take a look at the WebView Duo workflow probably as a more realistic example here.
Okay. So we do have when you are setting up the plugin, you receive a web view and a message bus. When like the web view is like the main and I'm freestyling here, right? I've reviewed the code, but I haven't used it in anger. But pretty much like the high level view is that every time that somebody opens a new website like this, like I copy it and I open another website, and okay, the language server is not running at the moment, but every time I open the website, this gets called, and you get a message bus, which is like a messaging frame, like a messaging tool that you get with that particular instance. So every time a new website is open with your web view, you get the plugin gets notified about it, gets the instance ID, and then gets a message bus that can communicate with that. And that's pretty much how you would work with that particular WebView instance in the plugin. You put all your logic that needs to handle that particular instance in this callback, and then the app there is a message bus. Resolve message bus is a JavaScript helper that gets called, and that on that website, it's implemented in a different package in the WebView client, and that opens the WebSocket connection into the plugin. That's the other side of what we saw here. So that message bus that you receive here is the other side of that pipe is created here with the resolve message bus. And then in index, you resolve the message bus, but you are not using it here at the moment. But you could if you wanted to. I think we just didn't get to it. But the resolve, like the message bus that you get from this method, would be able to communicate with the plugin. So that's the part here. And the patterns we will have to still establish as we go. Like, for example, how to structure. When I said that you should put the code that handles that particular instance in the callback, I didn't mean that all the code should live in the callback. But we don't, like John is implementing the chat web view at the moment, and I don't expect us to get the patterns right the first time, but it should be, unless we are creating something extremely complicated, we should be able to change it. You know, if it's a 400 lines of code that we implemented here, then we can refactor it when we figure out a better way to structure it. However, we are expecting that the message bus and the other parts of the plumbing are relatively stable. There might be some small changes to them, but like the idea that you have to establish this two communication lines, that's not gonna change. So that is already quite stable, even though the typing that we have rounded, the TypeScript types to type all the messages that are flowing through, might still have to change a little bit. Yeah, so that's probably all I'm equipped to present. This connection is something that I'll maybe ask John if he could do a follow-up. It's going to be nice that he's going to do it in a different time zone as well, since he's in Texas. And yeah, any questions to what we covered?
I do have, of course,
Of
I
course.
have to. So the code you showed about the web view in the extension, so that that dummy iframe
Yes.
wrapper. Do you have the MR for that? Because this is literally the work that I'm supposed to do today, and I would like to pick it up if you don't plan to finish it today, or if you do plan to finish it today, then it would be even simpler. So
Gotcha. Yeah, there is this. It's 1801 in the.
So it's the one by John, right?
Yes.
Right.
I just added a few comments to it to support the feature flag because.
Okay. So it's going to be the same MR that exposes the web views from language server and sets up the web view in the VS Code.
Yes, the one that exposes the language server part that exposes what web views are available, that's merged and in main, and the VS Code extension part that consumes that metadata is in progress. However, like we can hop on a call after this if you are not rushing off to lunch, and we can discuss it. I'm not extremely happy with how this is structured. I'm not sure whether I would like to build a lot of code on it before I get to time to restructure it a little bit. So I was thinking that it would be done by end of tomorrow, but if we are rushing to have it faster, let's have a Zoom chat and figure it out.
Okay, got it. Thanks.
Cool. All right. if that's all, then thank you for participating. It was very visible how unprepared I was, but especially with the new WebView stuff, it's still being made as we speak. But yeah, I hope you found it useful.
Thanks a lot, Thomas. It was very informative.
Yeah, amazing stuff. Thanks.
Thank you. I'll post the video soon on YouTube. All right. I'll see you all next time.
Have a good one.